Hello, Year 10. Hope you're keeping well. Today we're going to continue on with calculating things to do with the equation of a line. Today, as you can see by the title, we're going to try to calculate the gradient of a line, but not with a picture. We're actually going to do it with a formula. So this first example does have a picture. It's just going to help us think about things, and then all the other questions today are not going to have any pictures in them. So the question asks us to work out the gradient of the line that joins together points A and points B. So very similar to yesterday, we have two perfectly lovely points located on this line. You can see points A and B are nice points. So I'm going to go ahead and join them up like I did yesterday. And I can also see that there is 1, 2, 3, 4 squares across there. And there is 1 square up. So I can calculate the gradient by just doing my up divided by my across. Now, that's great, but like I said, and like the title said, we're going to be doing this with some kind of a formula because the rest of today we're not going to have a picture. So what we need to do is we need to think about how did they get the number 4? How did we get the number 4 besides just counting the squares? And how did we get this number 1 without just counting the squares? Well, if we think about the number 4, the 4 was how far we had to travel going across the graph. And going across the graph is in the x direction, so that would be this 2 here and this 6 here. So do you notice anything about the numbers 2 and 6 and the number 4? I don't know, think about it. I'll tell you in the next slide. And what about to get the height of the triangle? That is the y values, which are 3 and 4. Is there any connection between those two and the number 1? If you have figured it out, great. If you haven't, you might want to grab your pen so that you can go ahead and write down what I'm about to tell you. I feel like there's a lot of information on here. Don't panic. Just read it with me if you'd like. So it says to work out the gradient between any 2 points without a diagram, you will need to remember this formula. There is a very fancy formula. It's not that fancy, I promise, that you will need to remember. You're not going to get given it in a question. It's just one of those things that you're going to have to learn. And if you don't learn it, you're never going to know it. So the gradient, I'm skipping down here now. The gradient, which we call the letter m, is given by the formula m, the gradient, is equal to y2 minus y1 divided by x2 minus x1. So all that that's doing is it's subtracting the y values of the coordinates, and then it's dividing by the x values of the coordinates. And the y values tell you how much you go up, and the x values tell you how much you go across. So it's everything that we've been doing up until now. The diagram that's to the left of the screen looks really fancy at the moment. There's lots of things happening there, lots of colors. I wouldn't even panic about it. As you can see, it's just telling you that here's point A, and it has the coordinates x1, y1, and here is coordinate B, and it has the points x2, y2. Now, this all looks really fancy. Please do not panic. I will show you how to use this in just a moment. This right here, which I'm trying to put a red box around, is the only thing that you need to have written down from this particular page. All right, just this m is equal to. That's all we need to be writing down. All right, if you haven't done that, press pause and do that now, and I will show you how to use it in just a moment. All right, let's try this out. Work out the gradient of the line between the points 310 and 520. So hopefully you can recall that the gradient is given by y2 minus y1 divided by x2 minus x1. Now in every single pair of coordinates, it goes x and then y. So because this is the first one, I'm going to call it x1 and y1. And then in the next set of coordinates, I'm going to call it x2, y2. And then all that this becomes is a substitution problem. You've done a lot of substitution over the past few weeks, so I'm just going to substitute these different numbers into my formula. So I've got m is equal to y2, which is 20, take away y1, which is 10, divided by x2, which is 5, minus x1, which is 3. 20 take away 10 is 10, 5 take away 3 is 2, 10 divided by 2 is 5. So the gradient is 5. That's it. Question's finished. That's all you have to do. Okay? There is a lot of questions that people like to ask. What if I decided to call this x2 and y2, and this x1 and y1, everything would happen exactly the same. I would just end up with some negative numbers. I'll show you that on the next slide. All right, similar idea. I'm going to be crazy this time, and I'm going to order them differently. So it says work out the gradient of the line between 0, 6 and 2, 10. So I'm going to call this point over here x1 and y1, and this point x2 and y2. And like I said already, this just becomes a substitution problem, and we've been doing substitution lately as well. So let's go ahead and do this. So m is equal to y2, which is 6, minus y1, which is 10, divided by x2, which is 0, minus x1, which is 2. So that gives us minus 4 divided by minus 2, which is 2. Now, if I wanted to, I could do everything in a completely opposite direction. x1, y1, x2, y2. I'll show you that nothing changes. M is equal to 10 take away 6 divided by 2 take away 0, which is 4 divided by 2, which is still 2. So it doesn't matter which way you order them, as long as you don't suddenly change things up. You can't have x1 and y2 in the same pair. All right, let's try another example, maybe with some negatives. All right, no negatives just yet, but this one has a fancy twist at the end. So I'm going to go ahead and label these x1, y1, and x2, y2. And the gradient is going to be 12 take away 13 divided by 10 take away 12, which is going to give me minus 1 over minus 2. Oh, that doesn't look like a minus 2. Use your imagination. Which is equal to 1/2. Now, if you'd like to, you can write that as 0.5, but usually I like to keep them as fractions. All right, last example, let's add in a negative. Work out the gradient of the line between the points 6, minus 5, and 3, 4. So we've got x1, y1, and x2, y2. So if we go ahead and use our formula, we've got 4 minus 5. Okay, it's a minus 5, but there's already a minus in the formula, so we need to be careful of that. That one was already there, and the minus 5 belongs to the minus, or the minus belongs to the 5. Divided by x2 minus x1. All right, we work that out. That's actually 4 plus 5 divided by 3 minus 6. So we have 9 divided by minus 3, which is minus 3. So this line is going downwards. The gradient of this line is minus 3. It would be going like that. All right, that is all from me today. You can try some questions by yourself now. Don't spend more than 30 minutes on it. And the answers are at the end of the PowerPoint. Have a good day.